Hi everyone. Today we will see how we can model the protein structure by using a Fire server. Okay, by the name itself, we won't get the spelling of this fire. Actually, spelling is different. This is Phyre. Okay, so once you type in Google Fire, it will give you the page where you can see the homepage of Fire. This is the latest version, that is Fire 2.2, and if you scroll down you can see a portion where you can paste your amino acid sequence, and another option is available where you can give your email address, and job description option is optional. It will give the result in two ways. Once you enter the email address and enter the sequence here and just click on the fire search, it will directly give the result in this page itself, and one result will reach to your mail ID also. So if you want to keep your result for a very long time, not too long, because it is having some time limit, so within that time it will get expired. So if you want to take the result for some time, then you can keep a job description also, so that you will get a differentiation of this result with other set of email. Okay, so here I am going to give my mail ID, and here I am not going to give my job description here, and in this portion I am going to paste the sequence. I have already loaded my sequence here, so I am going to copy this and just paste it over here. Okay, so you know what type of sequence format is this? This is actually FASTA format. FASTA format is started with the greater than symbol, and then some description will be there, and the name of the protein and the organism name will be given, followed by the sequence of amino acid will be represented here. But in the case of most of the tools for modeling, they are depending on FASTA sequence, or they will be accepting only FASTA sequence for their further process. But in this page, or in this Fire database, or in the Fire web server, it will take any sequence, and not any sequence, a raw sequence. Okay, so I am going to delete this FASTA identifier, and I just kept only the sequence. So this we can call it as a raw sequence. And see here, one blank space is there, so I am going to delete that space. So now we can see that only the amino acid sequence is there in this portion. Okay, so Fire receive raw sequence of your amino acid, so you can paste only the sequence of protein or the amino acid sequence in this query box. Okay, and there is one more option is there. If you have you have already served your protein in a file, and if you want to upload that file directly here, you can choose this option, like choose file, and then you can load your protein sequence file here. Otherwise, if you want to enter the UniProt accession number, that also possible through this option. Okay, and modeling mode itself, they have given some different options. Some normal option is there, intensive mode, alpha thread mode, traditional Fire 2 mode, test mode is there. See here, I am going to choose only the normal mode, so I am just clicking on the normal option. All right, okay, now I am going to click on this Fire search here. Okay, so by clicking on this Fire search, now we have to wait for some time to get the result. Okay, actually some 4 or 5 steps are running behind the screen. What are the steps that we can see when we click on this Fire search and wait for some time? It will show different options or different steps that it is going to cover. Okay, okay, so what are those steps? Actually, there are some 6 steps will be running behind after we click on this search. So here you can see all these 6 steps we can see here, and by running these steps, it will give you the title of that step, what actually it is going over here. All right, so the steps, what are they? So I'll point out, finding homologous with the Cyblast, that is the first step. So SciBlast is a position specified iterative basic local alignment search tool. So it will search the similar sequences of the query sequences in all the databases, and then it will give us the result. Okay, so the second step is building hidden Markov model of the sequence. So hidden Markov model is actually, it is a statistical model of representing some problem. Okay, so here how it works. So it will train some non data, and based on that data it will create a model, and based on that model it will give you the output. So that's why it is how it works. So in hidden Markov model, actually in our upcoming videos we will be explaining in detail about this hidden Markov model. And after the third step, we can see checking for transmembrane helices. And after that, in the fourth step, we can see some constructing models. And then we can see that some loop modeling, and then generation of result page. So these are the 6 steps that is running behind this process after running the search button. Okay. The 6 steps will be going on here, so we have to wait for some more time to get the result. Okay.